All right, let's go ahead and do some second order linear differential equations with complex roots. Let's do a couple examples and we'll see what happens. So let's start, let's take y double prime plus 4y equals 0. That one's pretty simple, I think. Okay, so we're gonna do our same, we're gonna start with our same from the same place. So y equals e to the rt. Okay, and that's gonna leave us with r squared plus 4 equals 0. So r is plus or minus 2i. Okay, so now we could do this e to the 2i. I mean, we could go down this path. Let me write it down. There's nothing inherently wrong with that as a solution, but we just don't use it. Okay, instead what we do is we take our y of t and we say, you know what? Something that can be written like this can be written in terms of cosines and sines. So this is going to be, let's call it k1 cosine of 2t plus k2 sine of 2t. Okay, and yes, these constants could have some imaginary thing in them, but we don't even really worry about that. We sort of suck it under the rug, and that's just what we work with as the general solution here. Okay, and you could see, so if you take y prime of t is going to be 2k1 negative sine of 2t plus 2k2 cosine 2t, and then y double prime is going to be negative 4k1 cosine of 2t minus 4k2 sine of 2t. And now you can see that y double prime, our y double prime is negative 4 times y. Okay. So it will solve the differential equation. Okay, let's put that in blue. Okay. All right, let's take another example. Let's take y double prime plus 4y prime plus 8y equals 0. We're going to do the same exact thing. We're going to go ahead, we're going to solve by taking y equals e to the rt. Okay, so y prime is, of course, r e to the rt. Y double prime is r squared e to the rt. Okay, so we're going to get r squared plus 4r plus 8 equals 0. Okay, we're going to solve this again for the roots using quadratic equation. R equals negative b, negative 4, plus or minus square root of b squared minus 4 times 8 all over 2 times a. Okay, so that's going to be negative 4 plus or minus the square root of negative 4. We just check that, yes, divided by 2. So -2 plus or minus I. So again, there's nothing inherently wrong with saying y equals a e to the -2 minus I t plus b e to the -2 plus I t. In fact, for a lot of things later on in more advanced classes, you're going to want to do that, okay? But that's just not what we do. What we do here is we're going to take y of t equals some constant, let's call it k1, e to the -2t. Okay, so we're pulling that real part in front. Actually, let me put k1. Yeah, k1's fine. And then we're going to have cosine of t plus k2 e to the -2t sine of t. Okay, and that represents the oscillatory part, the cosine and sines. Okay, could all, yeah, that'll do. Okay, so we've gone through all the three different cases. We're going to go ahead and start solving some initial value problems in the next video.